but we don't need to consider all the aspects. So this is not necessary. Okay. And normally, I explained to you in the class, normally you only, okay, in a front of the problem, you may arise the things that you should design the controller directly and see what happened with the design. This is not enough. So this is also the topic of the today lectures. We focus on this. Okay, we learn about more about the plan or process, and we will see how many type of state space model we can represent for a plant. Okay, so this is topic. This is a state space canonical form. Okay, so this like a standard form. Okay, for some reason. In some reason, we need to transform the models into the canonical forms. It's easy to study about the system, and it also easy to find the solution of the problem you got. Okay, so first we look to the controllable canonical form. Okay, so again, it's like a standard form. I just you will remember that if you got a function ts equal as, sorry, bs over as like this. Okay. You can find that we have okay. Then we find that we can find that you have many ways to represent this in state space form. Okay, so we can represent it in this form. But this is not unique. You have several ways to express, to represent this. Okay, so we got transfer function and we convert it into state space. So we have transfer function to state space. But for state space, is not unique. Okay, from one transfer function, we have many ways to represent the system in state space. Okay, let me check it. Sorry. Okay, I think that we have enough students, and now I will turn on the security by turn on the waiting rooms. Okay. So you like to go to the room, you have to ask me. Okay. Okay. Okay, so we will see how many ways to represent this system in state space, and this is the first form, standard form. We call this a controllable canonical form. Okay, firstly, I would like to tell you that I update my slides, and in this slide, I change something from, okay, in the previous one or in my website, I put this form, ys divided by us. This is transfer function output divided by blah blah transform of the input. I got sm, okay, b naught plus b1 at n minus 1. Okay, plus bm. And here we got a naught n plus a1 and n minus 1 plus a naught. Okay, it doesn't matter, just we change the notation, and then now we change to this. The reason for this is that this is in the first course. In the first course, I come up with this form, and this form. Sorry, in the system one. So I would like to make it consistent from the course number one and system one and to system two. So that reason I changed this in this form, but it just changed the notation, nothing different. Okay. So in the slide on my website, it is slightly different, and I will update this lately. Okay, you can follow this. It doesn't matter, but I will update this some days. Okay, for use. Don't worry about it. If you see something different with the lecture slides and what available in the e-learning website. It quite normal because I told you many times I update my slide every day. Before the lectures, I will look back to my slide and change something if I think that this is necessary for use. Okay, so if we look at the transfer function in this form, okay. So this transfer function you already know in the system one. Okay, this is a output y, and here we got input use. Okay, so this is a Laplace transform of the output and Laplace transform of the input. We assume that all the initial condition is 0. So the controllable canonical form of this system can be like this. Okay, you can represent the transfer function of the system, and now we convert or transform transfer function into the controllable canonical form, or you can represent this system that by state space equation, and this is a form we got. Okay, so we have the x dot equal 1 dot okay, someone asked me to do some action. Oops, I don't know why up to now they still asking me to add, because 1 week more than 1 week passed. So please wait for me. I will see. Okay, during my lectures, please someone. Okay, maybe I'll have to ask. I think I asked all of you into here, but I don't know why they still have students not joined the class. Let me check. Okay, please. Hmm. Okay, now let me continue. So this is the controllable canonical form. Okay, so see that if you got this coefficient a naught, a1, sorry, a n, sorry. Oh, this is previous one. Okay, here. If you got here a n minus one up to a naught, then you can represent the system in terms of function here. But now we can represent this in this form. Okay, so we have 0, 1, 0, 0. Okay, and the first column here before the end, the last round, A0, 0, and we got A naught, A minus A1, minus A naught, minus A1, minus A2, up to minus AN minus 1. Okay, by this form. Okay, and for the input, we got 0, 0, 0, and we got 1 here. Okay, and we call this is a controllable canonical form. So CF is for controllable canonical form. Okay, and for the output function, the output equation represented by this. Okay, B naught A naught Bn, B1 An, A1 Bn, and O multiplied by Bn. And this is a C, and this is the D part. Okay, so you should still remember this should be, sorry, this should be X. Okay, Cx, Df. Okay, DUs. And okay,